Hello students, as in this lecture we're gonna start with the concept based on the second exercise. As I hope you all understood the first exercise. First exercise it was based on some conversion, that how to convert radian into degree, degree into radian, and then degree to minute, and then minute to second. Then after that we saw some statements, some based on triangle, quadrilateral, cyclic quadrilateral. When the angles of the triangles are in AP, when the quadrilaterals angles are in AP. And then we saw some more concept, that is how to find the exterior and interior angle of a regular polygon, and as well as in the last lecture we saw how to find the angle between the hour and the minute hand. So almost we had covered all the concept based on the first exercise, and today we'll see the concept based on the second exercise, and without knowing the concept we cannot able to solve the sums. So here we'll see some basic formulas of your 10th standard first, and then after that we'll see the main concept, main formulas of your 12th standard, sorry, 11th standard. Okay. And of course the formulas and the concept, it will be there in next few chapters also, maybe it will be there in 12th also. Okay. So first we'll see the basic concept. As we all know that this is what it is, a circle. This is the center of the circle. This 2 is what it is known as the radius. Yes or no? They are the radius of the circle. This is what it is, the angle made by this part. So you will take this as O, this as A, and this as B. So here this angle is what theta, which we used to say in 10th standard. Yes or no? As this formula it was there in mensuration chapter. Yes or no? How to find the length of the arc, area of sectors, area of triangle, perimeter of sectors, how to find the area of shaded region. All things, I guess, it was there in your 10th standard mensuration chapter. Yes or no? So we'll take some few concept, and then we'll start with your 11th standard. Okay. So here we know that this is what the radius. Yes or no? A radius. And this is the theta. The theta here in 10th standard, we know that the theta, that it will be in what? Degree. And here we'll take one more alphabet, AXB. Okay. So this AXB, this part is what we used to call as the length of the arc. Yes or no? We used to call this as the length of the arc. If we remove this whole section, okay, this part, this piece, if we remove, this will look like this. Yes or no? O A X B. This is the radius, and this section is known as what? The area. And this is what? The sector. Yes or no? So this section, the whole section is known as the sector. This part is known as the length of the arc. For a complete circle, this whole section, the outer region, is called the circumference. Yes or no? For triangle and perimeter, sorry, for triangle and rectangle, this outer region is known as what? The perimeter. For circle, we say that it is a circumference. For this section, this is known as what? Length of the arc. Yes or no? And this part is known as the area of sector. Okay. I hope you all might be knowing these basic things. Then after that, we all know the formula which was there in your 10th standard, that is length of arc, and the symbol which we use, it was L. Yes or no? And the formula, it was theta upon 360 into 2 pi r. Yes or no? We used to apply this formula, theta upon 360 into 2 pi r. Okay. And the second formula, it was area of sector. For area we used to take the symbol as A, and the formula it was theta upon 360 into pi r square. Yes or no? This was the two important formula which was there in your mensuration chapter. Yes or no? Length of the arc it was theta upon 360 into 2 pi r. Area of sector is theta upon 360 into pi r square. And there was one more formula for area of sector. I guess you all might be knowing. We used to write half r into L. Half into r into L. L stand for radius. L stand for length of the arc. Okay, how you got this formula? It is very simple. Okay, actually this two formula actually it is one and the same only. Suppose in place of r, we'll write this formula, that is theta upon 360 into 2 pi r. So here 2 will get cancelled. Okay, so theta upon, we left with theta upon 360 into 1, you will get theta upon 360 pi, and r into r we can write as r square. So it means this two formula actually it is one and the same. So just we had split this part, length of the arc we wrote as half into r. If we multiply this length of arc by half into the radius, you will get the area of sector only, like that. Okay, it means to say that whenever you multiply the length by half into the radius, you will get the area of sector. Okay, so this formula when you have to use when you have the value of theta and radius, and this formula when you have to use when you have the ready-made value of r and L. Okay, understood? So this was two formula which was there in your 10th standard, and the basic formula I hope you all might be knowing, that is area of circle. What was the area of circle? It was pi r square. And there was one more basic formula, it was circumference of circle. So what was the circumference of the circle? It was 2 pi r, or we used to write what? We used to write what? Pi d also, yes or no? Because we know that diameter is what? Twice of the radius, and radius is what? Half of the diameter. Okay, so area of circle we used to write half pi r square, and area of circumference of circle is what? 2 pi r, or else we can say pi d also. Okay, so this was the basic formula which was there in your 10th standard. So remember this section is known as what? Length of the arc. This is what? Area of the circle. For circle, we outer region we used to say circumference, and for triangle and rectangle we say perimeter. Okay, so now let's see the concept of your 11th standard. So here also we'll take the first formula as length of the arc. So here the symbol which we use for the length of the arc will be S, not L. Remember this. Okay, so for this exercise the length of the arc will take as S. So here the formula it is little different. Okay, here we will be using this formula for 11th standard, r into theta. So why so? Diagram it will be same, radius will be given, theta will be given, but in 10th standard we used to apply theta upon 360 into 2 pi r, and here the formula it is different. Why so? Yes, remember. Okay, I will explain why. Here why we use r into theta, just for a while just remember like a trick. Okay, okay, for length of arc r into theta, so there is a derivation part. After derivating some so and so thing you will get this answer, but in simple language I will try to explain this part. Okay, it is not the actual process. Okay, what I am showing now, it is not the actual process. The derivation part for this it is little different. Here it's my way, in my technique I will explain, try to show this why and how you got this r into theta. As we know that length of the arc which was there in 10th standard, the formula it was theta upon 360 into 2 pi r. Okay, so now suppose now we require this answer. So for a while, just consider this pi, it is in radian. It is in what? Radian. And we know that whenever we have to convert degree into radian, okay, simply you have to multiply it by pi by 180. Yes or no? So it will get converted into radian. So whenever in numerator you see pi, so we used to consider, okay, basically we used to consider whenever it is numerator it consists pi, okay, it is in radian. And for radian to degree, the concept it was 180 upon pi. So in simple language, whenever pi is there in the numerator, basically we consider it as the number will be in radian. And if pi it is there in the denominator, we consider it as in degree. So as the pi it is in numerator, so we'll consider this as in radian. And we know that the value of pi radian is what? 180. So 2 pi will be equals to what? 360. So here can I consider this 2 pi as 360? So this 360 and this 360 will get cancelled, and here we left with what? Theta r. So r into theta. So here just we took s, and there it was l. L and s, it is one and the same. Okay, just in the 10th standard we used to take the symbol as l. Here we write s. Okay, so the length of the arc s is equals to r into theta. I hope you all understood what I did here. Okay, so basically we consider whenever whenever pi it is there in the numerator, as per our point of view, it is what? Whenever it is there in the numerator, that means it is in radian. Yes or no? That we used to think. Okay, and whenever it is there in the denominator, in uh, in simple language I will say that we are converting that thing into degree. Whenever pi it is in the numerator, it means what? We are converting something into a radian. So here pi it is in numerator, so we'll consider this pi as radian now. Okay, just for a while consider this pi as radian. So pi, we know that it is 180. 2 pi 360. So we'll cancel this 360 360, so we left with r theta. Just it's my way explanation part, but in textual language I guess the derivation part is little different. Okay, I hope you all understood as how you got the answer. Okay, let's move on to the second one. So here the second one is what? Area of sector. So here area of sector we write as a only. Here the formula is different. Half into r square into theta. But there in 10th standard we used to write what? Theta upon 360 into pi r square. Okay, but here we have half into r square theta. Okay, now here we'll see. We'll consider again this pi as what? In radian. So what is the value of pi? That is 180. So 180 ones are 180 twos are. So here we left with 1 upon 2. We'll separate this part. 1 upon 2 theta and r square. So we left with 1 upon 2. 2 it is in denominator. So that means 1 upon 2 into r square into theta. Yes or no? So here we got your 11th standard formula. Okay, got the point? So the first formula which you have to use, the first concept for the second exercise is the length of r, that is r theta, and area of sector is what? Half into r square into theta. Okay, it is not, we can say like official we say now. The derivation part it is little different. Just in my way I explain the thing like this. Okay, just to make the concept clean and clear, that's it. Okay, so now as we know that intention there were two formula, so here also it has to be two. Half r will be r, and here L stand for what? Length of the arc. But here L is replaced by what? S. So here we write S. So for area of sector, here we have two formula. One is half into r into theta and half into r square into s. And see to that this formula which we got, actually it is with respect to the radian. So for the second exercise, see to it that the theta is, it has to be in radian. Here this formula which we got, it is with respect to the degree, angle it was in degree, and this formula here we got because we consider this pi as what, a radian here, yes or no? We consider this pi as radian here. So if we consider this pi as radian here, yes or no? So the formula which we got with respect to the radian, so the angle it has to be in radian only. So see to it that in the second exercise, whenever the angle it is given in degree, you have to always and always you have to convert that degree into a radian and then only find the answer. Okay, so here the first formula is length of the arc, it is r into theta, area of sector half into r squared theta, and the second formula it is half into r into s. So we'll move on to the third. The third formula it is common, area of circle. So we know that area of circle it is fixed, pi r square. Fourth one, circumference of circle, again same, 2 pi r, or else pi d, because we know that diameter is twice the radius, so radius will be what, half of the diameter. Okay, I hope you all understood till the fourth formula. So let's move on to the next one, formula number fifth, that is perimeter of sector. Okay, the perimeter of sector which was there in your 10th standard, this formula actually it was there, which we used to apply in the miscellaneous. Okay, in exercise I guess the formula it was not there in 10th standard, but in there was one sum in the miscellaneous where we used to find the perimeter of sector. Okay, so what do you mean by perimeter of sector? As we know that this is what sector, O A X B, and this is what the radius. This section, this part is the sector. So now we'll see how to find the perimeter. Perimeter means what? The outer boundary. As here just I had explained, for triangle this outer region, outer boundary is what? The perimeter. For circle we say circumference. Okay, this is known as what? Perimeter. So here can I say a circular region whenever we have, it is not a perimeter, we never say perimeter. Okay, a line, the outer region boundary, this is the perimeter. So here clearly we can see that here we have two lines and one curved part. So in the diagram we know that this curved part is known as what? This section is known as what? Length. Yes or no? The section is known as what? Length of the arc. Length of the arc, it is not a length. And here we have two length, which is what? The radius for the circle. Yes or no? As we know that this part is the length of the arc and this is radius. So perimeter means what? Sum of all the sides. Like here, if you want to find the perimeter of the triangle, okay, suppose this is A, B and C. So what we used to do, we used to add all the three sides. So here also we'll do the same thing, we'll add all the three part. But here clearly we can see that these are the sides, we can see in short simple language, and this is the length of the arc in simple language. uh, as here we have three part, so simply you have to add all the three part. So as here we have three part, we'll add this three part. There are two radius and one length of the arc. Yes or no? So the formula it will be what? R plus R, it will be 2R plus L. Okay, so here the formula it will be different. Here also same, this is radius and this is length. Yes or no? Length of the arc. But here for length of the arc we use the symbol what? S. So the formula will be R plus S. So therefore R plus R will be what? 2R plus S. Understood? Okay, or else we can use one more formula, 2R plus, in place of S we know that what is S? It is R theta, so we can write it as R theta also. So there are two formulas for perimeter of sector. We can use this formula 2R plus S or else 2R plus R theta. So that was the formula number fifth. Okay, so once again we'll see the formulas. The first formula is what? Length of the arc, that is r theta, and see to it that the theta it is in radian. It has to be in radian only, because here we got the formula with respect to the radians. Okay, and in the second exercise, whenever in the sums, if you see, if you come across the angle, the degree, it is in degree, you have to convert the angle in radian, and then only you have to apply the formula. Okay, so that is important thing. Okay, note theta, it should be in radian only. Okay, then the first formula is length of the arc, that is r into theta. The second one is area of sector, that is half into r square into theta, or else we can use one more formula, that is half into r into s. Here I had explained everything. Okay, have you got these formulas? Okay, area of circle, that is pi r square. Circumference of circle, it is 2 pi r, or else we can use pi d. And we know that diameter is what? Twice of the radius, and radius is half of the diameter. And the fifth one is perimeter of sector. So for perimeter of sector, we use r plus r into s. Perimeter means all the three sides, like that. Okay, so here we have two radius and one length. So for this exercise, we use length, the symbol which we use, the length, as s. So r plus s will be 2r plus s, and s is the length of the arc. So we know that length of the arc can be replaced by r theta here. So here we have two formula for perimeter of sector. Okay, so let's move on to the next one, formula number 6. Okay, so here the formula number is 6th will be what? uh, how to find the area of shaded region or a segment. Okay, area of segment, or we can say shaded region. Okay, what is segment? We'll see. As we know that this is what? A circle. Center of the circle, these are the radius, theta, it will be in radian. This is what? Chord. This is length of the arc. So this part is, suppose if you want to find this part, so this section is known as what? The area of segment, or else we can say area of shaded region. So here they will use the word sometime area of segment, or sometime they will use to find the area of shaded region, or sometime they will use the word the area enclosed by the arc and the chord, or sometime they will use in the question. Okay, that you have to find the difference between the areas. So now we'll see what is the meaning of this. As we know that area of segment means what? This section. Area of shaded region also that part. Area enclosed by the arc and the chord. So here we know that area which is enclosed by the arc. So this is the arc, this is the chord. So the area which is enclosed is this part. So indirectly or directly we can say it is segment only. Yes or no? So sometime in the question they will say that you have to find area of segment. Sometime this area of segment will be replaced by the word area of shaded region. Sometime it will be replaced by area enclosed by arc and the chord, or sometime they will say that you have to find the difference between the area. In short, in simple language, all the meanings are same. Okay, the formula will be same for all the four part. And what is the formula? We'll see. The formula is what? If you want to find this shaded region, remember this. Okay, now we'll see how to frame the formula. Okay, so here can I say, if you want to find this formula for this part, okay, now we'll see how to frame the formula. As we know that this part is what? The area of sector, this is the area of segment, and this is the area of triangle. So here can I say area of triangle plus area of segment. When you add this two part, area of triangle plus area of segment, when you will add this two part, you will get what? area of sector, yes or no? In short, I can say that yes or no. As here we have two shape, one is triangle, one is sector. When you add this two part, you will form a what? You will get a what? A shape called, that is the area of sector, as it is the half part of the circle, and we know that this part is known as what? The sector. So here we can we can create our formula. Area of segment will be equals to what? Area of sector. This area of triangle will go to the right hand side, minus area of triangle. So here we got the formula for area of segment. So if we got the formula for area of segment, so of course the formula will remain same for area of shaded region. It will be same for area enclosed by the chord and the arc, and it will be same for the difference between the areas. So here we have the difference between the areas. Difference between what? The area of sector and the area of triangle. So here the formula is what? Area of sector minus area of triangle. So for all the four case, the formula will be same. The formula will be area of sector minus area of triangle, and we know that the for area of sector, the formula is what? The formula is what? Half into r into s, and there is one more formula, that is half into r into theta. This formula you have to apply when you have the radius and the theta, and this formula you have to apply when you have radius and direct length of the arc. Okay, so here we have area of sector. So now we'll see the formula for area of triangle. So area of triangle, as we all know that area of triangle, okay, the basic formula is half into base into height, yes or no? Or there was one more formula in 10th standard, it was half into r square into sine theta. I hope you all might be knowing this formula. Okay, now suppose if you want to find the answer for this triangle, okay, and suppose here we have the height. So if you want to apply this formula, we require the base and the height. So if you have the base and height, easily you can find the area of triangle. Now second formula, when you will apply, when you have, if you want to find triangle and you have theta and the radius, with the help of radius and theta also we can find our area of triangle. So these are the two formula. With respect to that, we can find our area of triangle. One is what? If you have base and height, that's it, we can find our answer. And if suppose base and height it is not there, with the help of theta and radius also we can now find our answer. Here formula is half into r square into theta. Got the point? So these are the two formula which you have to apply here. So here the formula is what? Area of sector minus area of triangle. So for area of triangle, here I shown, took this as seventh formula. So area of triangle is half into base into height, or half into r square into sine theta also we can apply. Okay, got the point? Suppose here in this circle, if the shape look like this is the chord. Suppose if you come across this some like this, okay, circle, then triangle, and this, can I say this section, this shape is look like what? Having six sides, that means it is an hexagon. So whenever suppose if there are sums in the exercise based on hexagon, so we'll write it as, we'll take this as formula number 8. So area of hexagon, area of hexagon. So here the area of hexagon is, it is 3 root 3 upon 2 into side square. Okay, so if suppose in exercise the sums are based with respect to the hexagon, and hexagon it is attached to the circle, okay, and we know that here we have the radius value. So the sums will be with respect to the circle, so you will have the radius, okay, yes or no? But the radius it is for the circle, but as suppose is the radius, okay, for the circle. So indirectly can I say the radius which will be given for the circle, it will be equals to what? Sides of the hexagon. Yes or no? Just remove the circle and see this radius, it is for the circle, but for the hexagon it will be what? Side. So indirectly the radius will be what? Sides of the hexagon for that particular question. Suppose in that particular question it says that radius is 6 centimeter. Okay, so this is 6 and this is 6. Indirectly that radius of the circle will be what? It will be the side for the hexagon. Okay, so here we have the formula for area of hexagon, that is 3 root 3 upon 2 into side square. So that's the end of the concept for the second exercise, I guess. Okay, so as now we had covered all the properties based on the first chapter, as in the previous video lectures we had covered all the concept based on the first exercise, and this is the concept for the second exercise. So almost we had covered all the concept, okay, of the chapter, I will say. So in the first exercise we saw the conversion between degree to radian, radian to degree. Then we saw the conversion between degree, minute and radian. Then after that we took some statement sums. Then we saw how to find the exterior and interior angle of regular polygon. Then we saw in the last video lecture we saw how to find the angle between the minute hand and the hour hand. As in this lecture we did the concept based on the second exercise. So let's have a quick revision. So the first formula is length of the arc. Here we use symbol as S, R into theta. Area of sector is half into R square into theta. The second formula is half into R into S. Note theta, it has to be in radian. Area of circle is pi R square. Circumference of circle is 2 pi R, or else we can use pi d, because diameter is twice the radius and radius is half of the diameter. Perimeter of sector is R plus R into S. So R plus R we can write as 2R plus S, and S we can write as R theta. So this all thing I had explained in detail. Okay, so here the next one will be what? Next formula, which is very important formula, as in the exercise there are 3-4 sums based on this. Okay, how to find the area of segment, area of shaded region, area enclosed by the arc and the chord, or difference between the area. For all the 4 cases the formula will be same: area of sector minus area of triangle. Here I had explained how to frame the formula, how to form a formulas. Okay, as if you want to find this segment, formula for the segment. Okay, so here we have two shape, one is triangle and one is segment. When you add this two shape you will get what? Area of sector. So here we got the formula for area of segment: area of sector minus area of triangle. Okay, so the next formula, it was area of triangle, half into base into height. When you have base and height you will apply this formula. When you have radius and theta you will apply this formula. In both the cases you will get the answer for the area of triangle. It's depend on the value which is given. If you have base and height, apply this. If you have radius and theta, you will apply second formula. Suppose if you come across sums based on hexagon and this hexagon is attached to a circle, so R will be what? The radius for the circle. So indirectly or directly the radius will be for the circle, but the value will be for the sides of hexagon also. Okay, so this radius will be equal to the what? Sides of the hexagon indirectly. Okay, so area of hexagon is what? 3 root 3 upon 2 into side square. So that's the end of the concept for the second exercise. Okay, so the remaining part, remaining sums based on this exercise, we'll see in the next lecture. Till then, goodbyes.